Hello everyone. Our lesson today is about multiplicative inverse of a matrix. It's last lesson in unit 1. Okay, if we have a matrix A 3 4 2 5 and we want to get the additive inverse. What the meaning of additive inverse? The opposite sign. So it will be -3, -4, -2, -5. Okay. Today, inshallah, our lesson is multiplicative inverse. To get the multiplicative inverse, first we want to get delta. What's the meaning of delta? As we said in the last lesson, delta equals the determinant of A. Okay, let's remember how to get the determinant. We want to get the determinant 3, 4, 2, 5. As we said, first we start with 3. So we make 3 times 5 minus 4 times 2 and get the result. It will be 15 minus 8 equals 7. Here the value of delta equals 7, not equals to 0. So we have here a multiplicative inverse. First we have a condition. If the delta equals 0, so we have no multiplicative inverse. Okay, so to get the multiplicative inverse, must delta has a value. Okay, first we have a condition, delta not equals to 0, and we said delta, it means the determinant. Okay, we get delta. We want to get A minus 1, it means the multiplicative inverse. We write A minus 1, it means the multiplicative inverse of A. We have the multiplicative inverse of A equals 1 over delta, which is 1 over 7. Okay, here we have 7. 7 here, it's delta. Okay, and open matrices. We write in these matrices, first we exchange the main diagonal. Here we have the main diagonal 3 5. Exchange, so 5 will be here and 3 will be here. Okay, and change the sign of the other diagonal. What's the meaning of change the sign? 4 here will be -4, 2 here will be -2. Okay, يبقى first to get the multiplicative inverse of a matrix, first get delta and check the value of delta not equals to 0, because here in the rule 1 over 0 meaningless, we has no meaning. Okay, and write a matrix, exchange the main diagonal and change the sign of the other diagonal. Okay, here 1 over 7, it means all element in the matrix divided by 7. So A minus 1 here will be 5 over 7, -4 over 7, -2 over 7, 3 over 7. And this matrix is the multiplicative inverse of A. Okay? Let's take some examples. Number 1, find the multiplicative inverse if it exists. Okay. The matrix A, -2, 2, 3, -4. As we said, first we want to get the determinant, which is delta. The determinant of A, -2, 2, 3, -4. Start from -2. -2 times -4 minus 2 times 3 equals -2 times -4, which is 8, minus 6 equals 2. So the delta here will be 2. So here we have a multiplicative inverse. Why? Because delta not equals to 0. So the multiplicative inverse here equals 1 over delta, which is 1 over 2. Open matrices. Here exchange the main diagonal. Here exchange the main diagonal. So -4 will be here, -2 will be here. And change the sign of the other diagonal. So here will be -2 and -3. Okay, Here, all element in the matrix divided by 2. So here we have negative 4 divided 2, negative 2 divided 2, negative 3 divided 2, and finally negative 2 divided 2. And simplify it by using your calculator. Okay? Negative 4, divided negative 2, which is negative 2. Here, negative 1. Here, negative 3 over 2. And finally, negative 1. And this matrix is A minus 1. Okay, let's take another one. B equals half, 2, 3, 12. First, we want to get the determinant, which is delta. Delta equals the determinant of matrix B. Half, 2, 3, 12. So it will be half times 12 minus 2 times 3. Okay, which is 6 minus 6 equals to 0. Here delta equals to 0. So we have no multiplicative inverse. So B minus 1 is not defined or not exist. Why? Because delta equals to 0. Okay? We have another example. Find the value of x which make a x9 4x has no multiplicative inverse. What's the meaning of has no multiplicative inverse? It means, as the previous example, it means delta here equals 0. Okay, so get the value of delta, which is the determinant of x9 4x. X times x minus 4 times 9 or 9 times 4 equals 0. Why? Because here we have no multiplicative inverse. It's an equation. X times x, it means x power 2 minus 9 times 4, 36 equals 0. Move 36 in the other, so we have x power 2 equals 36. We want to get the value of x, so take the square root and don't forget to write positive or negative square root. So we have here two values of x, which is positive 6 and negative 6. Another example. We have here matrix A, which is negative 1, 0, 8, negative 2. Matrix B, negative 1, 0, negative 4, negative half. And we want to prove that B is the multiplicative inverse of A. What's the meaning of B is the multiplicative inverse of A? Get the multiplicative inverse of A. And must be equal the matrix B. First, get the determinant of A, which is negative 1 times negative 2 minus 0 times 8. So here we have negative 1 times negative 2, it will be 1. 1 minus 0, sorry, it will be 2. 2 minus 0 equals 2. So the determinant, the delta here will be 2. Okay? So here we have A minus 1 equals 1 over delta, which is 2. Open matrices. Change the main diagonal. So here will be negative 2, negative 1. And change the sign of the other diagonal. Here 0, it will be 0. 0, neither positive nor negative. And 8 will be negative 8. Okay. Make every element in the matrix divided by 2. So here we have negative 2 divided 2, 0 divided 2, negative 8 divided 2, negative 1 divided 2, and simplify it by using your calculator. Using your calculator, negative 2 divided negative 2, it will be negative 1. Here will be 0, negative 4, negative half. What did you notice here? Here we have A minus 1 equal the same matrix of B. Here A minus 1, negative 1, 0, negative 4, negative half. What about B? Negative 1, 0, negative 4, negative half. So here we have B is the multiplicative inverse of A. So B is the multiplicative inverse of A. Here we have another solution. We have here another solution. Focus with me. In this example, we want to know, or we want to prove that A is the multiplicative inverse of B, or B is the multiplicative inverse of A. Okay. We studied in first prep, if we have 2 over 3, its multiplicative inverse is exchange, it will be 3 over 2. So if we have multiplied together, the result will be 1. Here we talk about matrices. So the matrix A multiplied by the matrix B must be equal 1. 1 in the matrix, it will be identity. What's the meaning of 1? The multiplicative identity. So here we talk about the unit matrix. So we want here to prove that A times B equal the unit matrix, which is I. Okay? So here the matrix A, which is -1, 0, 8, -2, times matrix B, which is -1, 0, -4, -half. Okay. -1. Okay. Let's remember the multiplication. As we said, the first matrix, it will be a row. Second matrix, it will be column. So open a big bracket. Here, -1 times -1, it will be 1, plus 0 times -4, it will be 0. The second column, -1 times 0, it will be 0, plus 0 times -half, it will be 0. Okay, let's take the second row. Here, -8 times -1, it will be -8, plus -2 times -4, it will be 8. Second column, 8 times 0, it will be 0, plus -2 times -half, it will be 1. Let's simplify. Here we have 1, 0, 0, 1, which is the unit matrix, the identity. So we have here AB equals the identity or the unit matrix. It means B is the multiplicative inverse of A. Okay? The last example. Solve the system of the two equations using matrices. We studied in the previous lesson how to solve two equations by using grammar. Okay. First, get delta. Second, get delta x. Get delta y. And write x equals delta x over delta. Y equals delta y over delta. Okay. Here we want to solve also two equations of first degree, but by using matrices or by using multiplicative inverse. Okay. First, we want to check that the two equations are in the standard position. What the meaning of the standard position? It means first x plus or minus y equals the whole number. Here x plus or minus y equal the whole number. Okay. Right. Here matrix times small matrix equal matrix. Okay. And we write in the three matrix first, the first matrix. Here write the coefficient of x and y. So write first in the first matrix the coefficient of x and y. Here the coefficient 3, 2. Write 3, 2. Second, here we have 2, 1. Write 2, 1. Okay. The second matrix, write x and y. Third matrix, write the absolute term, which is the whole number, 5 and 3. Okay. We want to solve the two equations, or we want to get the value of x and the value of y. As we said in any equation like 3x equals 12. We want to get the value of x, so we move 3 in the other side by divided, so we get x equals 12 divided 3. Here also we want to get x and y, so move the matrix 3, 2 and 2, 1 in the other side by divided. What's the meaning of divided? It means we want to get a minus 1, which is a. Here we have a. So we want to get a minus 1. Why? To move a in the other side. Okay? Okay. To get a minus 1, first we want to get what? Delta, or the determinant. So we want first to get the determinant of a, which is 3, 2, 2, 1. Okay. 3 times 1 minus 2 times 2. It will be 3 minus 4, which is negative 1. So the value of delta here equals negative 1. To get a minus 1, it means 1 over negative 1, 1 over delta, and open matrix. Write in the matrix what? Exchange the main diagonal, here 1 and here 3. Change the sign of the other diagonal, which is here negative 2, negative 2. Okay. All element here will be divided by negative 1. So here we have a matrix 1 over negative 1, negative 2 over negative 1, negative 2 over negative 1, finally 3 over negative 1. And by using your calculator to get the simplify, we get here we have negative 1, 2, 2, negative 3. So a minus 1 is negative 3. So here we have xy, the matrix xy equals here a minus 1, which is negative 1, 2, 2, negative 3, multiplied by the whole number, which is here a 5 and 3. How to simplify it? By using multiplication. Here the first matrix will be row, second matrix will be column. Okay, so here we have a big bracket. Here negative 1 times 5, negative 5, plus 2 times 3, 6. The second row, 2 times 5, 10, plus negative 3 times 3 equals negative 9. So here we have negative 5 plus 6, 1. 10 minus 9, also 1. So the matrix x and y equals 1 and 1. So here the value of x equals 1. The value of y equals also 1. Okay, so here we have x equals 1 and also y equals 1. Don't forget to write the solution set. The set of ordered pair 1 and 1. Okay, thank you.